Hello students, today in today's video we will discuss about the gravitation and the numerical part of it. We will cover the numerical portion of the chapter in two parts. Today we will do up to 1 to 10, and on the next day we will do from 11 to 12. So let's start from first question. First question is the force of attraction between two bodies at a certain separation is 10 Newton. What will be the force of attraction between them if the separation is reduced to half? Now, force of attraction, gravitational force of attraction can be written as G m1 m2 by r square. Now, according to the question, the value of this force is 10 Newton. Now, we have to find the force when the separation is reduced to half. So, let that at that case, the force due to gravitation is Gm1. This is F1. This is equal to Gm1 m2 into by r by 2 square. Now, it will be equal to G m1 m2 by r square. Now, in denominator it is 2 as y, so it will be as 4 r by 4. So we can write it as 4 into G m1 m2 by r square. Now this G m1 m2 by r square is basically our force. So this is 10 Newton. So our answer will be 4 into 10 Newton, that is 40 Newton. Now do the next question. Next question is write the approximate weight of a body of mass 4 kg. What assumption have you made? Now we know that the formula of weight of a body W is equal to m into g. Now where m is the mass of the body, now given mass of the body is 4 kg and g is acceleration due to gravity, but we have to find the approximate weight. So we assume that the acceleration due to gravity is 10 meter per second square. So the weight will be 5 into 10, that is 50, and the SI unit of force is Newton. Newton. So the approximate weight of the body will be 50 Newton. Okay. Now do the next question. Next question is given. Uh, Calculate the weight of a body of mass 4 kg in kgf and in Newton. Now the given here, the mass of the body is 10 kg. So weight of the body in kgf unit will be 10 kgf, because kgf means kilogram force, that is kilogram into gravitational force. So we can write it as 10 kg force. But in Newton, the weight will be equal to mg, that is basically 10 into 9.8. So it will be 98, and unit of weight in SI unit, it is Newton. So in Newton it will be 98 unit, 98 Newton. Now again the question is same question, same type of question. State the magnitude and direction of force of gravity, of the force of gravity acting on a body of mass 5 kg. Now for this case, weight of the body is the force of gravity acting on it. So we can write it as G or F equal to mg. Now put the value m equal to 5 kg and g, we can write g as 10 to the 10 new 10 meter per second square or 9.8 per second square. Both are correct, but in the book the value of acceleration due to gravity is given 9.8, so we will take 9.8 here. So answer will be 49, 49 Newton. Now do the fifth question. Fifth question is, the weight of a body is 2 Newton. What is the mass of the body? Now for this type of case, uh, G is given in our book is 10 meter per second square. So now we will use the formula like W equal to mg. Now W is given 2 Newton, so 2.0 equal to m into 10. So m will be equal to 2.0 by 10, that is 0.2. This is in kg. If you change the unit, it will be 20 gram. Okay. Now do the next question. Next question is, the weight of a body on earth is 98 Newton. What is the mass of the body and what is the what is its weight on moon? Now we know that the formula W is equal to mg. Now put the values W 98 m into g. The value of g is 9.8. So value of mass will be 9.8, 98 by 9.8, that is basically 10 kg. Now on moon the acceleration due to gravity is 1.6. This is given 1.6 Newton meter per second square. So the weight of the body on moon will be equal to mg1, that is 10 into 1.6. So answer will be 16 Newton. Okay. Now do the next question. A man weighs 600 Newton on Earth. What will would be his approximate weight on Moon? Now we know that weight is basically mg. Then this is 60 Newton. But on Moon, weight will be equal to mg1, as the acceleration due to gravity on g will change, and that is 1/6 of our Earth's wa- acceleration due to gravity. Now put the value, you will get 100 Newton. What is the force of gravitation and weight of a body of mass this? Now do the value like force of gravity of gravitation and weight are same. So we can write F equal to W equal to mg. Now mass of the object is given this 10.5, and acceleration due to gravity you can write it as 10 meter per second square. So answer will be 105 Newton. Now do the next question. Next question is, a ball is released from a height and it reaches the ground at ground in 3 seconds. Find the height from which the ball is released and the velocity at which it will strike the earth. you will strike the ground. Okay. Now for this, it is given G is equal to 9.8. So for first case, we will use H is equal to half gt square. Now put the value half into 9.8 into t is 3 into 3. If you do the calculation, the value of this will be 44.1 meter. And for v, the velocity with which the ball strikes on ground. So for this we will use v equal to gt. Now put the value, g is 9.8 and t is 3. You will get the result. Result will be 24 or 24 or 24 or 29. 29. It will be 29.4. Yeah, 29.4 meter per second square. Now to the last question of today. What force your muscle need to apply to hold a mass of 5 kg in your hand? For this you will use this thing, W is equal to mg. Put the value 5 and g is 9.8. If you do the calculation, you will get 49. So to hold a mass of 5 kg on your hand, you have to apply a force of this Newton, 49 Newton, on your muscle. Okay. Now in today's lesson, we will do only this 10 question. If you stuck on this, if you stuck on this any of this question, you may comment on my video, and we will do the next 11 to 20 number question on our next video. Up to then, thank you and God bless you all.